Alright, so let's look at a question from UNEB 1997, and this was question number 2. So we're being told to evaluate the integral of tan cubed x dx. So this is slightly different from the former ones in that we don't have sine and cos directly involved, so we have a tan. But good enough, there is a relationship between a sec and a tan. So that's what we're going to be using mainly in this section. So now the integral of tan cubed x, how do we do it? So the first step is we know that this can actually be represented as tan x times tan squared x dx. But also, now we're going to convert this tan squared x now into the form of sec squared. So that's going to be the next step. It's because now we know that tan squared x is actually the same as sec squared x minus 1. So we're going to be using the knowledge of the relationship between a tan and a sec, actually, and a sec squared. So basically, when we open these brackets, we'll have tan x sec squared x minus tan x. So now I can say that I can actually split this into two different integrals that will be worked out independently. So now I believe we've seen how to work out this in the beginning of the section, and then now this is the one that we actually mainly have to look at. So let's deal with that. So as I can see this, I can already see that there is actually a relationship between a tan and a sec. So what I actually see is if I make a u to actually be equal to tan x, and then if I differentiate that, I'll get sec squared x somewhere. And I believe that will help us eliminate the sec squared x right there. So I'm going to let u to be equal to tan x, and then du dx is equal to sec squared x, and then if I make dx subject, dx should actually be equal to du over sec squared x. So plug that back in and I'll have the integral of, so there is tan x, I put u sec squared x times this, so I have times du over sec squared x. So as you can see, as I've said, this will actually cancel out with that, and I'll be left with the integral of u du. So that means that was actually the correct substitution. So if I integrate that, the integral of u is u squared, it will actually be equal to a half u squared plus c. But remember that u is tan x, so therefore it means I have a half tan squared x plus c. How about the integral of tan x dx? I think we've already worked on this at the beginning of this section, but remember that what we had to do was to convert that tan x into a sine x over cos x dx, and then we can actually use u substitution. We're going to let u to actually be equal to cos x, and that's because there is a relationship between the derivative of a cos x and a sine x. So when we let u to be equal to cos x, du dx should actually be equal to negative sine x. So if I make dx subject, dx should actually be equal to negative du over sine x. So therefore, when you plug that back in, we'll have sine x over u times negative du over sine x. And then therefore what I'll have is this. As you can see, this and this cancel, and I'll be left with the negative 1 over u, of which I can take the negative out of the integral. Then the integral of 1 over u is actually ln u, so I have negative ln u plus c. But remember that u is actually cos x, u is cos x, so therefore I'll have negative ln u cos x plus c. So therefore the integral is tan cubed x dx being equal to a half tan squared x minus ln cos x plus c. So there are two different ways of expressing this answer. I just chose not to simplify this even any further, but actually I could have made this negative power negative 1 here, and I would have a 1 over cos x, which is actually equal to sec x. So actually this could have been a positive ln sec x plus c. So this could actually, the answer could also be a half tan squared x plus ln sec x plus c. But anyhow, both answers are actually correct, and all of them will be marked. Alright.